figure out how to do it.
Not really sure how to add it.
You should be able to just, did you see the up arrow on the left?
Yeah.
That allows you to paste something. Or you can just hit paste, do the paste button. You can just paste it if you're on a computer.
Now I'm on my phone. I could read you the
Oh,
buttons.
oh, you're on your phone. Okay. Yeah, maybe it's easier for me.
I can send it to you on Gmail too.
No, it's okay. I have it here.
Okay.
I can do it. It's okay. I just have to use like yeah, it might be easier for some of these. It might just be easier for you to, like, I don't know why, but I can't just copy and paste them. I have to like save it, photo, and then I have to import the photo in or something. So it's just a little bit annoying.
Yeah.
Photo library. You see that okay?
Yes.
All right, so it says solve over the interval.
Oh, that's not mine. That's pre-calc.
Oh, okay. Maybe I didn't get yours then. When did you share it?
I shared it like a little less than an hour ago. I called it S1.
And it was a Google Drive,
Yeah, Google Doc.
Google Doc. You shared it to 204 Tutor.
Yeah, 204 or napervilletutor@gmail.com.
I'm sorry, yeah, Naperville Tutor. Questions for, oh, no, that's not it either, right? There. Wait, is that it for 1211? No. S1 review.
Yeah.
Okay, I don't know why it took so long to pop in there. Okay. All right. Like I said, just a little bit annoying because I got to do this. I'm gonna do it for all of them real quick right here, so it's easier for me to pull them in when I'm ready for them. Yeah, it's a bummer. Google used to have a much better way to do this, and they stopped supporting that,
Mm-hmm.
which is a big bummer. Okay. The last one that I have, you can just, if you want to just tell me. Let's see, hold on. Delete. How do I delete this?
It's like a
Got
track.
it. I don't know if I got the very last one, but I got the other ones. So 1, 2, 3. All right. Look right? Look good?
Yeah, those are the right ones.
All right. So sketch the graph. Include x-intercepts, asymptotes, removal, discontinuity. All right. So can you see it okay if I just zoom in and do it right on here?
Yeah, I can see it.
So it seems like you did a lot of it. So what were you having a hard time with?
The part I was having trouble with is I found the removable discontinuity, but it didn't really seem like it would fit where the graph would go.
Okay. So
I found it at
you said that the removable discontinuity, oh yeah, which yeah, it's not 8,7, it's 8,1/7.
oh
Right?
yeah.
So that's why.
Okay.
So the hole right there, you're right about that. And then the graph is going to look like this and go that way,
Okay.
right? And
Yeah.
then it's got to be on the other side as well. If you plug in 0, you get -1. So that's another point that you can use. The y-intercept of -1. That's a good point to have. And so that's what your graph would be.
Okay. So that was just a silly mistake. Got it.
Yep. Number 6, why does h of that cross the x-axis at x equals 0? That's because of this factor. That's why. So
Okay.
x is kind of like saying x minus 0, right? You can think of it like that. So it's kind of like x minus 0, x minus 4, x plus 5.
Okay.
How would h of x have to change to make it have no negative values? You could square all of them, I guess. Squaring them all, because right now you're going to cross. Right now it's going to cross at 0, at -5, and at +4. So it's going to, how would you change to have no negative values? Well, it's going to have negative value there, right? And then it's going to have a negative value here. So to get rid of both of those, what you could do is you could make that squared, and it will make it bounce.
That would never go into the negatives.
That would never go in the negatives, and then you can square. I think probably the answer they're looking for is just square all of the factors.
Square all the factors. Okay.
I think. I mean, that's definitely would do it, right? Because then it would bounce, and it would bounce like that.
Yeah.
You get what I'm saying? So I think that's what they wanted you to say. I
Okay.
think that's what they're after. So you'd have 6. So there's 5 turns. 1, 2, 3, 4, 5. Yeah, there's 5 turns, and it would never cross down into the, like, there's you. And anytime you have a pos, or like a 1, it means it's going to cross the 0. So in order to not cross the 0, you have to at the minimum you have to square all of those.
Okay.
Does that make sense?
Yeah.
You want it to bounce each time, so just square all of them. Yeah. So that's what they wanted. Number
Okay.
5 says write the equation of the quadratic with the vertex of that. So your vertex that goes through that point. So use your vertex form. Y equals a times x minus h squared plus k. Right? You remember that?
Yeah.
And then plug in your h and k. H, k. So you don't know a yet. So that's what we're going to try to find. So +9 squared minus 3 equals y. And now plug in this for x and y. 0 and -54. So plug in 0 for x and -54 for y. So -54 equals a times 81 minus 3. So add 3 to both sides. You get -51 equals 81a. Divide both sides by 81. A equals -51 all over 81. 51 is divisible by 3. So you can cancel out a 3 from both of these. So this would be 27. And this would be, what's 51 divided by 3? 17. So A is 17 over 27. Sorry, -17 over 27.
17 over. Okay.
Okay, so then rewrite the equation. Y equals -17 over 27 times x plus 9 squared minus 3.
Okay. Is that it? Is that just the answer?
Oh my gosh, I did that totally wrong. I plugged the wrong thing in for h and k like a complete idiot. So sorry. Start over. Like, that was kind of a weird answer, but yeah. Sorry about that. It's a little late. All right, so let's try that again. I plugged in the wrong thing for h and k. I said the right thing, and then I plugged the wrong thing in. So it's y equals a times x plus 3 squared minus 9. Got it? Now plug in -54 for x and 0 for y. So -54 equals 9a minus 9. Add 9 to both sides. You get -45.
Yep.
equals 9a, so a equals -5.
Yep.
There you go. So now rewrite it. Y equals -5 times x plus 3 squared minus 9. That is your equation. So sorry about that.
Okay. Yeah, that makes more sense.
I mean, you can get ugly answers, but if you do it the wrong way, you'll get wrong, ugly answers, which you don't want. All right, what was your question on this one?
For which ones?
This one that you have here. Is it this that you had a question about?
I had a question about all three because those are on my test and I got
Oh,
wrong.
got it. All three. So what are they asking you to do? Just simplify them?
Yeah, simplifies the expressions.
Okay, so 20 plus 10 over x divided by, was this divided by in parentheses? Was it like this? 20 minus 5
Yeah.
over x squared? Is that how it was?
Wait, what does the difference make? Like what is the parenthesis?
Well, the way you've got it written up here, this is dividing only that.
Oh no, it's dividing the whole equation. So yeah, parentheses.
Okay, so there's parentheses because that does make a difference, a pretty big difference actually. Okay.
Yeah.
So just make sure you're aware of that. So, couple ways that you can do this. So I'm gonna just, whoa, what the heck just happened there? I'm going to write this out differently. Okay, I'm gonna write it out like this. Because I'm going to show you the way that I prefer doing this problem.
Okay.
Some teachers don't teach this, but I just think this is so much better. You'll notice that this is the biggest denominator, right? So we're gonna multiply the top and the bottom by x squared over x squared. We're gonna multiply both the top and the bottom by x squared. Okay. And the reason we're gonna do that is because then it'll clear out that part of the fraction. So that gives me 20x squared plus 10x all over 20x squared minus 5. Okay.
-5. Okay.
And see how I don't have a compound fraction anymore?
Yeah.
So now I'm going to just simplify this. So notice that I can factor out a 10x from the top. And that would leave me with 2x plus 1. And I can factor out a 5 from the bottom. And that would leave me with a 4x squared minus 1. Still not done. Because now this here is a difference of perfect squares, right?
Yeah, so it could do 2x plus 1, 2x minus 1.
Exactly. So it's 2x plus 1, 2x minus 1, and 5 there. And now I can cancel things out. Now the 2x plus 1s cancel out because they're factors of the entire numerator and the entire denominator, and the 10 and the 5 can cancel out. And I'm left with the 2 at the top. So 2x is at the top, and 2x minus 1 is at the bottom. And you might have to say that x cannot equal -1/2.
Okay.
I don't know if some teachers don't make you say that, but I would say that because technically you canceled out an x, right? A factor that involves an x. So that means that this is slightly different. Kind of think of like your holes, your removable discontinuity. It's like there's a hole at x equals -2. So you should really put that domain restriction in there.
Okay, I had a question.
Uh-huh.
So why couldn't you just cancel the 20x squared from the top and bottom?
Hold on. X also can't equal 0 because look at the original. See that original thing? You can't divide by 0. So a 0 is not part of the domain of the original function.
Okay.
Also, you really should do this. Again, I don't know if your teachers make you do this, but you should say that can't equal 0 as well. So solve that equation. So -5 over x squared cannot equal -20. So 5 cannot equal 20x squared, which means 1/4 So x can't equal plus or minus 1/2. So we already said it can't equal negative 1/2. Oh, and we know it can't equal positive 1/2 either already. So you don't really have to say that because you can already see that it can't equal. You can see that it can't equal positive 1/2 already right there because it's still in your problem. But you can't see in this problem, you can't see that there used to be that factor there. And you can't see that there used to be that over there from the original thing. You get what I'm saying? So again, I don't think your teacher, actually, I don't think the teachers make you do that, but I think that's probably the proper way to do those problems. What was your question now?
Oh, that was it for that one.
Okay. Now you were going to ask me something and I cut you off. That was all you were asking?
Yeah.
Okay. So I'll do this other one up above it here. So 5x plus 17 over x squared plus 5x plus 7 minus 3 over x plus 7. So if this factors here, you should factor it. Does it factor? 7 is 7 and 1. Nope, it doesn't factor. So you sure that was the problem? This is kind of a weird looking problem.
Pretty sure it was.
Okay. So what you're going to have to do for this is get common denominators. So you're going to have to multiply this by that on the bottom and on the top. And you have to multiply this by that on the bottom and the top. So you have common denominators. Got it?
Yeah.
So doing that, and you go ahead and FOIL that whole thing out. Doing that, the bottom is just going to be x plus 7 times x squared plus 5x plus 7. And you don't need to FOIL that out. But you do need to FOIL these out and multiply this. And don't forget about that negative. Right? So I'm going to change this to a plus and a -3. So I don't forget to distribute that in. So multiplying this out gives me 5x squared plus 17x plus 35x plus what's 17 times 7? 119.
Yeah.
Okay. Minus 3x squared minus 15x minus 21. So now simplify that. That equals the x squared. So it's 2x squared. And 17x and -15 is 2x. So plus 37x. To get all the x's, there was 3x terms in there. Yeah. And then 119 minus 21 is
98.
98 all over x plus 7 times x squared plus 5x plus 7. Now, the only thing you really have to worry about here is if this top thing can't factor into something that would cancel out. So you're asking yourself, can that factor? Is there an x plus 7? Is 98 a multiple of 7? It is. It's 14. So this probably is going to factor, I'm guessing. So the reason I said that is because in order for the only way that you would have to simplify this more is if this had an x plus 7 in it. And if it did, this would have a 2x plus 14. So let's see if that worked. I don't think it does work actually.
The equation was wrong. Instead of
Sorry, not
squared plus 5x, it was x squared plus 8x. So now it's factored.
Oh, got it. Okay. So that changes kind of everything.
Yeah.
Yeah. That the way that was written looked kind of weird to me. So I just misread what you wrote out. My fault. Okay. Yeah. You were done with, if that was it, that you were done. There was nothing more you could have done to that one, the one that we did before. So in this case, and this is what usually it looks like this, because now you can factor that into probably x plus 7,
X plus 1.
X plus 1, right? So now instead of having to multiply both of them by something, you only have to multiply this by x plus 1 over x plus 1, right? You get that?
Yeah.
So now your denominator is x plus 7 and x plus 1, and the numerator is 5x plus 17 minus 3x minus 3. So now we can simplify that. So that's 2x plus 14,
Yeah.
right? Over x plus 7 times x plus 1. And now this factors 2 times x plus 7. Got it?
Yeah.
Then this cancels here and here, and you just have 2 over x plus 1. But remember, x cannot equal
-7.
-7. Good. Does your teacher make you write that?
Yeah.
Okay, good. Perfect. I've seen some teachers that don't actually make you write that,
Okay.
but I think you should. Definitely should. Okay.
Mm-hmm.
Got it. So this last one there is, I'll do it down here, x over x plus y over x minus y. So for this one, again, I'm going to get common denominators to simplify this. I need to multiply this by x plus y and x plus y. And this I have to multiply by x minus y over x minus y. That'll give me common denominators. So my answer is going to be, notice this is just going to be x squared minus y squared, right? If I FOIL that out, or just don't even boil it out, just leave it for now. Maybe that would be easier because there might be something canceling out. X plus y, x minus y. That's factored form. So multiply this together, you get x squared minus xy. Multiply this together, you get plus xy plus y squared. And those cancel each other out. So you just get x squared plus y squared, which does not factor over what you have there, which turns out to be x squared minus y squared. So that's your final answer. Those can't simplify any further.
Wait, so that denominator you can write as x squared minus y squared?
Well, yeah, because when you FOIL it out, what are you going to get? That middle term's going to go away. You're just going to get x squared. Sorry, you're going to get x squared plus a negative y squared.
Okay.
These middle terms, remember x minus 3 times x plus 3. Remember what happens to that? It's just
Yeah.
x squared minus 9. It's just the difference of perfect squares.
Okay. Got it.
Okay, good.
Yeah.
Good with those three.
Uh-huh.
All right. When graphing a quadratic function, you notice the axis of symmetry is located at the same x value as the x-intercept of the function.
Yeah, so for that one,
What must be true? So it's quadratic, so just draw it in. Put it right there. And the x, you notice that the axis of symmetry is located. So the axis of symmetry is at the same place, the x value as the x-intercept. So if that's the axis of symmetry, what has to be true? If this is your x-intercept.
there's only one.
Yeah, there's only one, and that would be your vertex. So the discriminant is negative. Nope. There's exactly one real solution. Yes, there is. And nope, that's not true.
It could be anywhere.
Yeah, it could be anywhere.
Okay.
Like at the picture I just drew. The vertex form of the quadratic is identical to its factored form.
No.
So let's pretend like this is 2. So it'd be y equals x minus 2 squared plus 0, right?
Yeah.
So that's the vertex form. And what's your factored form going to be? Y equals x minus 2 times x minus 2, which is really just y equals x minus 2 squared. So that's actually true also.
On the answer sheet, it said that B was the only correct answer. So
Well, they must be assuming that you would write your vertex form like, or your factored form like that. I think D is correct also.
Okay.
Yeah. I mean, this is factored form technically because the two factor, you're just, at least that's how like factored form can have multiplicity, right?
Yeah, because it
Yeah.
bounced.
Yeah, it can show multiplicity, right? Isn't this factor form if you did something like this? Isn't that factored form?
Yeah.
Right. So yeah, I think D is also correct. Maybe bring that up to them.
Okay. I have my final tomorrow, so if I can before, then
Yeah,
I'll.
yeah. That definitely seems to me to be B and D, and that's why they say all correct answers.
Okay.
Number 19 says if that where AXN is the term with the highest degree, which of the following is true if all zeros are shown on the given graph. In other
So,
words, it doesn't keep coming down like this. Eventually, is what they're saying, right? Or going up like this, because technically it could. So they're saying that all the zeros are shown on the graph.
so I narrowed it down to C and D, but I was kind of confused how you figure out if it's an even or odd
F
number.
of X has, so we can tell that it's going to have, so we know it's going to be an odd, it's going to be odd degree, right?
Yeah.
We know it's going to have a positive leading coefficient, right?
Mm-hmm.
And we know that it has 4 zeros and there's no bouncing. So it's got 4, 1, 2, 3. And we know it's a fourth degree polynomial.
It does have a bump at 4. That's a bounce.
Oh, it is a bounce. My bad. Yeah, yeah. It's not a 4. It has 4 zeros, but one bounce. One bounce. Thank
Okay.
you. Yeah, which it would have to be. So it's a fifth degree. It's an odd degree. It can't be a 4 degree, right? So what's true? Fx has no double roots. That's not true. It has one at 4. F of x has one double root. Yes, that is true. A is a positive number. A is the leading coefficient.
Oh, yeah, it is.
Yes, you know that's a positive number. Yeah, because it's going up from left to right. This going up at the end means it's a positive number.
Yeah.
Got it?
Mm-hmm.
A is a negative. No, that's not true. N is even. No, N is odd. Yes. So it's 2, 3, and 6.
So
2, 3, and 6. So D.
do you figure that out by the end behaviors?
Yeah. N behavior means it's odd degree.
Okay.
If the N behavior is going in opposite directions, then it's an odd degree.
Okay.
Good.
Yeah.
Okay. Your last question said write a quadratic with real number coefficients if one solution is 6 minus 7i. Okay, hold on. I've lost my Zoom. Okay, there we go. 6 minus 7i. So have I shown you this trick before? 6 minus 7i is 1 0. That means what's another 0?
6 plus 7i.
Good. So here's the trick that I'm going to teach you. I'm going to prove it to you. If I have zeros of um, 3 and 2, what's going to happen when I multiply this out into standard form? What am I going to get?
X squared uh minus x minus 6.
Good. So it's like minus 1x, right?
Yeah.
So notice that this is the sum. It's the opposite of the sum of the zeros because your zeros were 3 and -2.
Yeah.
Right? So that's the opposite of the sum. And notice this is the product of the zeros. So that gives you the little shortcut that I'm going to teach you. Your shortcut is this: y equals x squared minus the sum of zeros times x plus the product of zeros. Okay.
Yeah.
So what's the sum of these zeros?
12.
Good. See how easy that was?
Yeah.
X squared minus 12x. So now we just have to find the product, and that's not hard either. Because if I multiply these together, what's going to happen to the middle term?
It cancels out.
Yeah,
So
and you're just going to get 36 minus 49i squared. And what's I squared again?
-1.
Good. So you just get 36 plus 49, which is 85.
Yeah.
So plus 85. Done.
Okay.
That's the easiest way to do that. The other way to do that is to write it like this. X plus, actually, hold on. X minus 6 minus 7i times x plus, sorry, no, did that wrong. Times x minus 6 plus 7i, right?
Yeah.
And now I got to do three things. Now I got to do this. 1, 2, 3. Well, first of all, I got to distribute these negatives in. Plus, negative, plus, negative, minus. I got to multiply that x all the way in. So that's x squared minus 6x minus 7ix. Then multiply to the negative, or the -6 in. So -6x plus 36 plus 42i. And then multiply the 7i in. You get what I'm doing? Plus
Yeah.
7ix minus 42i minus 49i squared. Man, that's a lot of things you can make mistakes with, right?
Yeah.
That cancels with that. That cancels with that. This becomes a -1, so that's a positive 49. And notice what you end up doing. That adds with that. So it's x squared minus 12x. 36 plus 49 is 85. You're going to get the same answer, but there's just a lot more places you can make mistakes.
Yeah.
Okay. So remember that little trick I taught you. And if you can't remember what the formula is, just do a simple example like I just did up here. Right? Think about if my zeros were 3 and -2, what would I get? And then just do that. You're like, oh yeah, this is the opposite of the sum, and this is the product.
Okay.
Okay.
Yeah.
So again, y equals x squared minus the sum plus the product. Sum of zeros, product of zeros.
Okay.
Good?
Yeah.
All right, you got more questions for me? We got about 5 minutes.
Just look. Can you go over the like quadratic regression, kind of like the word problems? I can send one.
Yeah, just say it. Just read it off to me.
Okay, a basketball player shoots a ball up into the air. Assume the ball takes on the path of a quadratic where x is horizontal distance of the ball from the starting point and h of x is the ball's height above the ground.
Okay.
At the time of the shot, the ball is 6 feet off the ground.
So
The ball
that's good.
eventually reaches a maximum height of 16 feet, then moves back towards the basket. After swish, the ball was 6 feet off the ground, 20 feet away from the original shot.
Okay, so 6 feet off the ground,
Yeah.
20 feet away. So this is 20. So we know that these 2 points are symmetric, right?
Yeah.
So because of that, we know that the vertex has to be halfway in between them, or the line of symmetry, axis of symmetry, which is the vertex. Going to give you the vertex. So that's going to be 10, right?
Mm-hmm.
And so we know that that point, 10, 16, was my vertex.
Yeah.
Yeah, I came up with that. So the vertex is 10, 16. That's my vertex. And what's the question then?
How many horizontal feet away from the original shot does the basketball hit the ground? Round to the nearest thousandth.
So they want to find this point right here.
Yeah.
That's what they want to find. So come up with your equation. So your equation is going to be y equals,
X minus 10 squared plus 16.
yeah, you could do that. Or you could just do a, you could put it in factored form also. So we don't know a yet, but we know that the zero, oh, no, we don't know the zeros. So sorry. Yeah, never mind. You could do something like what I'm saying, but that's not a good idea. So a times x minus, sorry,
10 squared.
x minus 10 squared plus 16.
Yeah.
And we know this other point, we know that one of the points is 0 comma 6. So
Yeah.
we're going to at 0, 6 equals a. So negative 10 squared plus 16. So that's 100. A plus 16 equals 6. Subtract 16. So negative 10 equals 100a. So a equals negative 1/10. So your formula is y equals negative 1/10. X minus 10 squared plus 16. And we're going to, now we're going to try to find out when it actually, what the 0 is. So now let's plug in 0 for y. Got it?
Yeah.
Because we're trying to find the x-intercepts. So subtract 16 from both sides. Multiply both sides by negative 10. 160 equals x minus 10 squared. Take the square root of both sides. So the square root of 160 plus or minus the square root of 160 equals x minus 10. So x equals 10 plus or minus the square root of 160. Now, minus the square root of 160 was going to give us this point over here. Let me just show you what we did. This right here, that point would be minus the square root of 160.
That wouldn't work, right?
Right, which isn't what we want. So this is plus the square root of 160. I'm just explaining that to you to help you understand that you actually don't need the minus for this one. It's
Okay.
10 plus the square root of 160, and then you can just punch that in your calculator if you need a round it to certain.
Okay.
Okay. So the square root of 160 is going to be
12.649.
yeah. So 2.649 would be the answer. I'm sorry.
22.
22.649. Yeah.
Okay.
Good.
Could you plug in the other point instead of the 0, 6? You could plug in the 20,
Yeah. Yep. You could. It would just be harder to do that. Actually, it wouldn't really be harder. It'd be the same thing. But yeah, always plug in the easier numbers if you can.
Okay.
But yeah, that would give you the same answer.
All right.
All right, you good?
Yep.
All right, man. Good
Thank you.
luck tomorrow.
Thank you.
All right, see you, bud. Have a good one.
You too.
What's up, Johnny?